All right, Foundations of Math 11, here we go. Let's get after it. Video 9, we're talking interest and loans, and we're looking at how interest can either help you out, make you money, or with a loan, how interest owes extra money. And it can be pretty awesome when you're saving, and it can be pretty brutal when you borrow, particularly when we look at compound interest, which is the second one we'll look at in this video. So the first one is simple interest. It's simple because the interest is charged kind of one time, and it's still nice, but it's definitely not as helpful as compound interest. But let's talk about these variables. I is your interest, and your interest is the amount of money you either get or extra or that you owe extra, and it's given in dollars. P is your principal, and spelt principal, and it is also dollars. R is your interest rate, and it is an annual interest rate, so your yearly interest rate, and it is 0 point something because it is a percentage written as a decimal. So as an example, 6% is 0.06. And then time is always given in years. So if time is in years, great. If time isn't in years, you need to convert it into years. So if you had something like 238 days, well, that's not even a full year. So it's 238 of 365. That's now a yearly fraction. If you had 10 weeks, well, that's 10 of 52 weeks, which gives you a yearly amount. So just be aware of that. It happens sometimes. Your time always has to be represented as a yearly time value. So let's just look at some examples. So here we go. We have an investment of 8 grand. So that means my principal is $8,000. We have an interest rate at the end of the statement there of 6%, so 0.06. And we have time of 5, and it is in years. Great. So find the future amount. Well, interest is equal to PRT, so my interest is equal to 8,000 times 0.06 times 5, which gives us an interest of $2,400. That's fantastic. That's $2,400 in 5 years for doing nothing. So how much do you have then, the future amount? Well, your amount is equal to your principal plus your interest. So we have 8,000 plus 2,400. So we end up with a new amount at the end of 5 years of $10,400. So pretty nice. You've earned $2,400 for doing nothing. That's why interest is amazing. So let's work this backwards. Willow borrowed $5,200. Okay, so borrowing is still your principal at an interest rate of 7.5%. So 0.075, because that first bit is your 7%, and the half follows. And she paid $23.40 in interest. So in this case, we know how much interest she paid. We don't know time. We don't know the term of the loan. So let's figure this out. I equals PRT. So in this case, 2340 is equal to 5,200 times 0.075 times T. So you can do this however you like. You get comfortable with your calculator. You'll get easier doing this in one step, but I'm going to demonstrate. I'm going to multiply the 5,200 and the 7.5% first, and we get 390, and then times T. So then we divide both sides by that amount, and you get T is equal to 6. So that means the term of the loan was 6%. Now, oftentimes what you'll see if you finance items, they'll calculate how much interest you're going to owe, they'll plug it into your total, and then they will divide that over a set amount of repayment periods. So in this case, if we're making monthly payments over a 6-year period, well, 6 years times 12 months is 72 months. So that means we had to pay off, one, our new total. So we had to pay off not only the 5,200, but the 5,200 plus the interest. So 5540. We had to pay that off, or sorry, 7540. We had to pay that off in 72 months. So what is the monthly payment then? Well, we just take our principal plus our interest and we divide it by the monthly frequency, and you get 104.72 and then 22222. In this case, we would actually round to 104.73, because if you round it down, you're not actually going to pay it off. You'll be short by fractions of a penny, but you'll still be short. So we'll round up. So the monthly payments are $104.73. So that is simple interest. Now, the next thing we're going to look at here is what's called a discounted loan. I have never actually seen this before. By no means am I an expert at any of this stuff, so I'll just try to explain this as best I can. Now, for a discounted loan, you see here Katrina gets a 2-year loan, so time 2. Well, the loan is going to be your principal of $6,000, and the rate is 8%. Now, what happens here with a discounted loan is you pay the interest off the bat, and it gets discounted from the loan that they provide. So first we need to calculate the interest that we're going to owe on this loan. So if we crunch these numbers, 0.08 times 2, we get an interest amount of $940. So what'll happen, or sorry, $960. So what'll happen here is they'll take that $960 and they'll subtract it from the principal. And what that'll give is $5,040. And what they do is they give that to you as your loan. So they basically charge you the interest right off the bat. But the thing is Katrina's still going to have to pay this back, but she pays it back as $5,040 instead of the loan plus the interest that has accrued. Now, the only sort of misnomer here is what happens now, what's the actual interest rate on the amount of money they gave her, because they didn't actually give her the full $6,000. So if you take the new principal of $5,040 and you take the interest of $960 that she paid, she's not actually going to receive the full $6,000. So her interest rate of 8% isn't an accurate reflection of the interest she paid. So if we calculate this, we actually have $10,080 times R, divide both sides by 1080, and we get an R value of 0.0952. So the interest of $960 on the amount of money she actually got was 9.52%. So the 8% isn't actually an accurate reflection of the interest she paid because she never actually got all the money anyways. So it's a weird roundabout way of looking at a loan. Again, I've never seen this before. You got a few questions in your workbook to practice, but please don't stress too much about this one. I'm more interested in the compound interest and the simple interest. So here is, as I was just mentioning, compound interest. So this one's amazing, okay? It can be amazing if you're making money, but also brutal if you owe money. A in this case is no longer the interest charged, it's the amount, okay? So A is not just the interest, A is the principal plus the interest already. And now R is the same, interest rate, annual. T is the same, time in years. But the new one, P is still your principal in dollars. But the new one is N. N is what we call compounding periods. And it's compounding periods over a year. So what that means is how many times is the interest calculated in the 1 year. So your annual interest rate, you'll see this R here is being divided by N, because if your interest rate compounds more times a year, you still only get that annual interest rate. It just means the interest gets charged more often. So you start to build interest on your interest, which is absolutely amazing. So if you have N, you could have a compounding period of 365. That means it's compounding daily. You could compound monthly. You could compound semi-annually. You could compound annually. You could compound weekly. You can compound quarterly, 4 times a year. All these different values represent compounding periods: daily, monthly, right? Semi-annually, annually, weekly, quarterly. So what happens is the interest gets accrued and gets calculated in multiple times a year, which means you build interest on your interest. It is an amazing thing if you're saving money. And to sort of demonstrate to you that, let's look at an example where we are making compound interest instead of simple interest. So here we go. I have a principal of $25,000 I'm going to save for my child for university. Now, not everybody has $25,000, but if you do, you can see how quickly money makes you money. So that's the whole point. If you have money right now and you're saving it up, save it up and then throw it in a savings account, and you'd be amazed at how quickly that money will make you money. So we have an interest rate of 6%, 0.06 right here, compounded quarterly, so N is 4, and time is 18. So in 18 years, how much money are we going to have? So here's our equation. A equals P times 1 plus R over N to the N times T. Now I'm going to show you the best way to crunch this if you're a bit of a calculator novice, because I don't want you to have to write down numbers, and you also don't want to be rounding, because when you round, you cut off values. Don't round to the very end. So first thing I would do is I would do this calculation of 4 times 18. And 4 times 18 is 72, so I would rewrite my equation with that exponent, 72. And then I would be aware of the button on my calculator, either y to the x probably, or a little hat. That's your exponent button. So now when it comes to calculating this, you're going to want to go in BEDMAS order. So this first. So just take your calculator in your hand, and you should have a calculator that holds values time after time. So if you go 0.06 divided by 4, you'll get 0.015. Now I'll write these numbers up here, but I don't want you to write these down. I want you to hold this all in your calculator, because now you go plus 1. And now you'll have 1.015. And then you hit one of these to the power buttons, and you go to the power of 72. And now you have 2.9, and then a whole bunch of decimals. And then right away go times 25,000. Boom, you get an A value of $73,028.95. That is huge. Now that is your amount, so that's how much money they're going to have in 18 years. To get the interest, you subtract the principal from there, but that is a wild interest calculation. That is how fast compound interest can make a difference on you. Obviously, the more principal you have, the better off you'll go, but that is how it works. So let's see if we can work this backwards. What happens if we have a 10-year bond? So in this case, time is 10, and the interest is 0.042. And we want a final amount of 5,000. So what we're doing here is we're just running this with the missing p-value instead of the a value. So we're going to have a little bit of algebra to do, but nothing overly major. But again, this is going to come down to how we can key this into our calculator. And we are looking at compounded weekly, so n is 52. So if we throw this in, we get 5,000 is equal to p times 1 plus 0.042 divided by 52, all to the power of 52 times 10. So again, my first step would be to change that 52 times 10 to 520. And now what I'm going to do is I'm going to go 0.042 and divide it by 52. What that does, that takes your annual percentage rate and divides it into the percentage per compounding period, which is a small percentage, but it's happening more often. Then we're going to add 1, and then we're going to put that to the power of 520. And in this case, you get a value that's 1.52 da 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 da. Now, you're going to want to keep that in your calculator, because in order to solve for the principal, we just divide by that amount. So in your calculator, just hit 5,000 divided by, and then the ANS button, the previous answer your calculator held in. And if you have a good calculator for this, it should come out at $3,285.79. So this using these equations is really comes down to a lot of, do you know how to use your calculator efficiently, because that'll really help. But then otherwise, it's more about those in-depth conversations of how good compound interest can be, how bad compound interest can be, how saving at a young age really will affect your life in a positive way if you have the means to do so. But even if you just consider $100 a paycheck, $50 a paycheck, and putting that into an account that you don't even think about, it's going to grow fast. And 10 years will happen before you know it. And it'll help you 10 years from now, trust me. What we're going to look at in the next video is something called an annuity, where you put fixed payments into a compound interest scenario, and you'll see there how quickly that money can build. So keep that in mind. If you have a job or you're getting a job and you don't have crazy expenditures, and you find you have a couple $100 kicking around, try to get a regular payment into an account that earns you interest. It will change your life. Thanks so much. I'll see you next time.